Okay, good afternoon, everybody, and welcome back. A reminder, project proposals are due tomorrow. That's Tuesday, and they're due at noon. So make sure you do that, because that's a very important opportunity for the staff to give you feedback on your project idea and make sure that everything is going to be a great experience for you and your team. So today's topic is usability or user experience, and for today and Wednesday, I'm going to be focusing primarily on what are called usability heuristics. In some sense, these two lectures are a distillation of really a huge number of ideas that have been taught for the last, I don't know how long, 5 or 10 years in the course 6813. But that course is not being offered this year, so we thought it was really important for you to have an opportunity to hear about these ideas. And what I've done is I've tried to distill them all down into 2 lectures. So there's really too much material here for 2 lectures. But I think you'll be able to grasp all this because most of this is pretty straightforward stuff. If rather interesting, I think it's really cool stuff. But it doesn't require great intellectual insight to understand what these things are about. So if I could ask you to close your laptops, that would be great. Thank you. If I recall, I'll send you out a link to one of those research articles that talks about how having laptops in class, it's interesting, not only detracts from the learning of the person with the laptop open, but it detracts from the learning of the person next to them as well. So there you go. So the 3 topics I want to talk about today are, first of all, a little bit about why we care about usability and user experience at all. And the truth is, I don't have any great insights on this, and we could talk about it for a long time, and it's very important. But I think you're probably already convinced. If you're not, let's chat afterwards. But I wanted to say a few things about that. The first is that user experience is really ultimately about quality of life, right? That increasingly we spend more and more of our lives using software. And so we, the people who create software, are responsible for the quality of life of all the people who are using this software. And if the software is clunky and hard to use and painful, it's not just that it has economic downsides, right? It's not just that the startups who make the cool software, won't be able to have their exit and, that their founders won't make billions and so on. We'll actually be degrading the quality of life for millions of people. And if you think about the designs that have had the biggest influence, in the last century, the sort of iconic designs outside software, they're normally designs that have been known to sort of really resonate with people at an emotional level. We're not going to be talking a lot about emotion. I will mention it, actually, in a couple of respects later. But it's important to understand that this is ultimately a large part of what usability is all about. It's about basically having a better life. So there in the middle is the famous La Mocha coffee maker. This is actually rather a puzzle to me because I own one of these. I mean, they're irresistible things. When you see one, I at least can't resist buying one. Its usability is near catastrophic. But that's another matter. It's almost impossible to make good espresso in one of these things because it's actually got some quite serious conceptual flaws. If you're interested in coffee, I will bend your ear on that afterwards and tell you why I think it's not the right design. The Leica camera, on the other hand, that has spawned just a whole century of imitators, and even digital cameras. The Fuji X100 that I showed you a photo of actually when we were talking about conceptual design problems is so close in design to that actually when I look at that picture, I wonder if I've put the right photo there, and that I'm actually showing a camera from 1953 and not from 2015. But I am, because I can actually just about read the writing on the lens to see that that's not a Fuji lens. This device on the left is really interesting. It's designed by Dieter Rams, who's one of the sort of most famous designers of the 20th century. He designed all of the products, or most of the products, for the German company Braun. All kinds of electronic, hi-fi devices, clocks, and so on. And this device became very famous. This is actually a transistor radio that was designed in 1958. And it became very famous much later because Jony Ives, the Apple's designer, basically chose that to be what he wanted the first iPod to look like. So the iPod and the iPhone have moved a little away from that design style. But I think if you look at that, you can see in its minimalism and elegance a lot of sort of Apple-ish design tendencies. And of course, it's important to remember that UX is not just in these devices, these kinds of everyday objects, and it's not just in software. It's in all the things that we use in life. That we make an effort, even in presentations, to make the experience of watching the presentation one that is a good user experience, whether it's in toys or in books. This book I really love. It's a design of Fahrenheit 51 by Ray Bradbury, which is about the burning of books. And the book cover itself has like a matchbox sandpaper on the side and comes with a match, so you can actually set the book on fire if you choose to. So these are sort of, if you like, the spiritual reasons for good design. But of course, the more mundane reason is that if you design your product badly, then you might have a total failure. And this is one of the most famous examples of failure. The truth is, I suspect that things are failing for usability reasons all the time. It's just that it's very rare for the stories to come out quite as clearly as this one did. So Avon, which, as you might know, is this company that sells cosmetics door to door, basically, it's a company that got into trouble largely because its business model no longer made sense. It was predicated on the assumption that women were home during the day and ready to be sold cosmetics by a door-to-door salesperson. They had this big idea that they would innovate by providing their salespeople with pads, with tablet devices, rather than with traditional sort of boards with pencil and paper. And that way they would be able to show their products better, and everything would be great. Here's what they actually said. And they made a big announcement about it, about their plans, which they said was going to revolutionize everything. But then later they said the following. They said, although the software worked as planned, it was so burdensome and disruptive to the representatives' daily routine that they left in meaningful numbers. In other words, all these people who worked for them and went door to door said, this software is so unusable, we're out of here. And so it was actually a catastrophe. And the Wall Street Journal blog had a really interesting take on this. First of all, they pointed out what happened. They pulled the plug on this $125 million software rollout. And then here's the Wall Street Journal's analysis. The failure is the latest and perhaps most dramatic example of how usability has become a critical issue in the workplace. People who are accustomed to using simple, well-designed applications in their personal lives have no patience for disappointing technology at work. So it's pointing out two things. One is this remarkable trend for things to be more and more usable, which raises the bar, and also this interesting disparity that there's been for a while between personal devices and personal software and the kind of software that runs inside corporations. The other thing, of course, is that even if you don't have a UX disaster, UX is now seen by a lot of companies as a product differentiator. And Apple, of course, is a controversial company in that respect, and we'll have an interesting discussion later about some ways in which some critics think that Apple has actually turned back on its commitment to usability. But there's no doubt at all that, that 20 years ago, I don't think anyone would have predicted that you could get someone to spend $1,000 on a phone. And this was really due, I think, to Apple's remarkable idea of making a product that was so attractive that it would just blow the competition out of the water because it was just, irresistible, an irresistible purchase. Okay, so that's all I want to say on this question of why UX is important. So let's talk now about what we're trying to achieve. So what does it actually mean to have good usability? So the first thing, of course, is ease of use. But ease of use is not just one quality. There are, in fact, at least three qualities that you can identify in ease of use. So the first is that you want your system to be learnable. The second is that means that somebody who's never seen it before can come up and make sense of it and hopefully grow in their understanding of the system just by using it. Second, that it should be efficient, meaning that when you become an expert, you should be able to use it quickly and efficiently. And thirdly, that it should be error tolerant, meaning that if you make mistakes, you shouldn't be punished for making the mistakes, that the system should actually help you. So I don't think there's anything remarkable in these ideas, but to solidify them for you, What I'm going to do is I'm going to show you a series of little designs, and I'm going to ask you how they rate on each of these 3 axes, okay? So here's the first one. This is the way signatures work in Apple Preview. So I don't know, how many of you have seen this? So it's kind of an extraordinary interface, actually. So if you want to sign a document, a PDF in Apple Preview, then you click on this thing saying signature, and it gives you this little instruction. It says, OK, if you want to do this and you have your cameras ready, click here. And then what it asks you to do is to hold up a sheet of paper on which you've signed your name. And so you hold the paper close, and you align it. You align the paper to the camera against that blue line. And then it does a nice little bit of image processing, and it extracts from that a high contrast signature. So the question is, how do you rate this on learnability? What do you think? Is this easy to learn? Total silence, but you're nodding. What do you think, Billy? Pretty good? Yeah, Billy thinks it's reasonable, so we'll go with that. I would say this is basically as good as it gets, right? It's very hard to imagine how you could be confused by this. And what's wonderful about this is, it's taken out the whole question of using a scanner or anything like that. How about efficiency? Is this efficient? If you wanted to do a lot of these, would this be a good way of doing things? Jackson, you're shaking your head. Yeah, this could be quite a nuisance, right? And also, if you wanted to have multiple signatures and sign them all on one sheet, then that wouldn't work very well, would it? Because this only would do them one at a time. So arguably, this isn't a very efficient design. And it actually also has some conceptual design problems. One of the problems with this is that because, and this is often a consequence of making a very simple design with a single path, is that this has a very fixed operational principle, which is that you follow these steps to create a signature. And in particular, it doesn't allow other paths. For example, you cannot upload a file that has, in fact, you can't download or upload these signature files. They're sort of embedded inside the app. And that, of course, makes for very good usability for the novice user. But it means, for example, that if you're a little bit more sophisticated and you want to have your signature stored on multiple machines, right, you can't easily transfer your signatures. And if you've got old signatures that you've recorded as GIFs or whatever, you can't upload them into this app. So there are some problems with efficiency. How about error tolerance? Do you think this is tolerant to errors? Michael?
Yeah. I feel right off the bat it lacks the button to say, like, try again if the signature doesn't work. So there's no indication of what signature is allowable, what's not, and what you should do if it fails.
That's interesting. I mean, you can press the cancel button. And in some sense, it is showing you what the preview looks like. So if you don't like it, you can press cancel and try again. But you may be right. If you can't get it to work, it's not going to help you very much. It's just going to sort of leave you there struggling. My sense was that at the very least, it gives you this feedback as you position it. But Michael might be right, that if other things start to go wrong, it's not going to work very well. Okay, here's a second example, which is a favorite of mine. So I'm not sure that this is used so widely anymore. Actually, I think it's still used in a bunch of cars. So you see these preset buttons, right? So the idea is that you can set these buttons to be your favorite radio stations. And in the olden days, the way this worked was that there was some horrible sequence of steps you had to go through. You had to press a special button for storing a radio station. And then an instruction will come up, now set the tuning. And then it would say, when you're ready, press this. Sort of inviting you to be doing this as you're driving on the highway and have a horrible crash. But then someone had this really great idea that you could do something different, which is that you could simply make it work so that if you had it set to a particular frequency, if you held down a button and held it until it beeped, right, then it would set that button to be that frequency. Okay, and if you press the button just very briefly, it would switch to that frequency. Okay, so what do you think about this? Is this a learnable design? So that's interesting. Darius?
No, there's no indication that you should be holding the button
Yeah, that's right. So that was my reaction. So I think the reason that people were sort of, nodding and saying it is learnable is because once I've told you that, it's really not very hard to get it. So in that sense, it's learnable in the sense of if you have the right education, you won't forget it. But I think Darius is absolutely right that perhaps the better word here would be discoverable. This is absolutely not discoverable. You would never know this unless someone told you or you'd seen it before. How about efficient? Is this efficient? Yeah, it's about as efficient as it gets, right? And how about error tolerant? Yes, Billy.
Not really, because I feel like if you have something saved at number 2 and then you press it but accidentally press it too long, then you won't overwrite what you previously had.
That's exactly right. So as Billy points out, there's this subtle sensitivity to how long you press the button for. And if you press it for too long, then you lose your previous setting, and that's that. Okay, how about this one? Dropbox deletion. So when someone shares a folder with you in Dropbox and you choose to delete it, it says, "Are you sure you want to delete this, this folder from your Dropbox?" Is this learnable? Yeah, obviously. Is it efficient? Yeah, it's pretty reasonable. How about error tolerant? Well, at least it has the cancel button. Yeah, Jonathan.
When you delete it and then realize you shouldn't have deleted it, I don't know if that recycling bin.
Yeah, I'm not actually sure whether it will be in your recycling bin. It's a good question. The problem is that Dropbox does indeed use that concept that we described in the last week as the trash concept, but it might only use it if you're the owner of the folder in the first place. In fact, the problem is that Dropbox behaves in very different ways when you delete a folder, depending on the role of that folder. If it's the root of a share, then deleting it is equivalent to leaving the share. If the folder is, in fact, inside something you're sharing, it will not only delete it from your drive, it will delete it from the drive of everybody sharing it, including the owner. So that's what I called last time a non-uniformity in the operational principle, which is potentially very confusing. And what's worrying about this is that when you press that delete button, it isn't actually even warning you that you're going to delete it from everybody else's Dropbox as well. So that, I would say, is really not an error-tolerant design. Now, one thing that's important, I think, to appreciate about these criteria is that they are in conflict with each other. Typically, you can't build a system which maxes out in each of these dimensions. So just to give you one obvious example, think about learnability versus efficiency, right? Typically, the way things work is that the more learnable systems tend to be less efficient. It's possible to try and have expert modes and things like that, but in general, these are in conflict. So imagine you're trying to do photo editing. There are apps like Pixlr and things like that, which are designed to make it super easy. So if you look at the sort of power of the user against time, you get a lot of power very quickly, but you can't go that far with it. But if you look at something like Photoshop, on the other hand, Photoshop is designed to be extremely powerful, but the basic concepts are so complicated that, until you've really got your head around layers and masks and so on, there's really not much that you can do very effectively. So you have a lot of time where you have very little power, but then once you start to understand things, you get a lot more power. So the point is that, you can't have your cake and eat it, basically. You have to think about these criteria of ease of use and decide which ones you're trying to optimize. Okay, so that's the whole category of ease of use. Let's do another category. So this is one that isn't always talked about in computer science, but it's related to this sense of sort of emotional satisfaction. And it's, of course, common in architecture to think a lot about, what makes a pleasant experience. This is the famous Ryoanji rock garden in Kyoto. There are increasingly people who are paying attention to this in software. This is one of my favorite examples. This was from a Kickstarter project a while back. A credit card-sized cell phone designed to be used as little as possible. So the idea was to make a phone that was completely unobtrusive, really small, and that would sort of change the emotional experience of using a phone. I don't know if you've seen it, but someone came up with an even better version of the phone, which was a plastic brick. Have you seen this? I forget what it's called, but you can Google it. A plastic brick which has no functionality at all. It is just a plastic brick. But it gives you somehow the emotional, comfort of having a phone-like thing, because you can stroke it and put it in your pocket and so on. But it is completely inert. And it's worth Googling this, because what's amazing about this brick is that they sold it for something like 20 or 30 bucks, and they sold a lot of them. So you have to wonder why. But I would say there's some desire out there for devices that are just comforting, even if they have no functionality. There is, in fact, a whole kind of field that this evangelist, Amber Case, who was actually here on sabbatical at MIT last year, has been promoting, which is this idea of calm technology. And the idea is to design a user interface so that it basically treats you in a nice way and makes your life better. And she has a list of principles in her book, and they include things like not demanding attention from the user, trying to communicate without noise. So instead of buzzing and ringing and things like that, to gently flash lights and things like that. And to use a minimal amount of technology and to use peripheral vision and things like that. Okay, so that's the criterion of pleasantness. Now I want to talk a little bit about safety. Safety is an interesting one because people often think that safety in user interfaces is just for things like this, inside an aviation cockpit. Obviously, safety is critically important, so you've got to design your usability with that in mind. But there are things all around us that are unsafe if they're not designed properly. You just look at, for example, the spigots that you typically have on water coolers, right? And they do special things. Like if you look at the hot one, you can see that that is designed differently, right? It's designed so that you can't just flip it on by mistake. You actually have to do a more sort of concerted action to get the boiling water to flow. And it's not just signaling, it's also sometimes preventing users from doing the wrong thing. And one of the common mistakes in sort of usability design for safety is to think it's good enough just to give people messages. This is one of my favorite examples, which I haven't seen recently, but used to be there for years in Heathrow Airport. So for some reason, they thought it was important to have really hot water coming out of the taps. And rather than actually reduce the water temperature so people wouldn't get burnt, they just put this sign saying, warning, very hot water. So kind of great. So there are people whose research is focused on improving usability for safety reasons. And Harold Thimbleby is such a person. And this is a little video this is taken from his work. And he did this fantastic project where he looked at all these infusion devices. And these are used, for example, to control chemotherapy drips and anesthetic drips and all kinds of things like that. And the basic idea is that the nurse or doctor enters the prescription in terms of a flow rate into the device, and then the device mechanically delivers the medication at that flow rate. But watch what happens when we actually press the buttons on this device. So the 0, we're going to enter a dose into this device. You press a 1, and now watch what happens. Then, did you see that the decimal point was pressed? Maybe I have to do that again for you. I don't know how to do that. Or like this. Now watch this carefully. 0, decimal point, 1. So you can see that what the person was trying to do was enter 100.1, but the decimal point was simply ignored without any message. And the result is that the dose that actually got recorded is 10 times larger than the dose that was expected. And this is, as you can imagine, this is not an academic problem. This is a very serious practical problem. And in fact, the FDA issued a recall for this particular device and many other devices, and noted that there have been about they'd received 56,000 reports of accidents, adverse events due to these things, and they estimated that they've caused more than 500 deaths. And you've probably heard about the Therac. How many of you heard about the Therac 25? Yeah, so the Therac 25 was a radiotherapy machine that killed a lot of people. But the tragedy of the Therac 25 is that we didn't learn the lesson, and that a bunch of years later, people were still making Therac 25-like devices. This was a famous example from Panama City, where they made a system that required the person operating it to essentially mark with a mouse on the screen where the shielding blocks were, so that they wouldn't be able to calculate the amount of radiation to be delivered, knowing that it would be attenuated by these lead shielding blocks. And it turned out that if you wanted to put multiple shielding blocks in like this, it sort of didn't let you do the obvious traversal, and so you had to devise a different, or the nurses discovered a different way of doing it. But it turns out that the way you actually clicked, the order in which you clicked around the blocks, produced a different dose. And that ended up killing 18 people. This was a very famous incident in Afghanistan where they had this plugger device which was used to bring in airstrikes. So basically the device was used to send GPS coordinates to an overhead bomber. So what you would do is, you would be a soldier on the ground, and you'd come across some insurgent, stronghold. Maybe you were in a fight with this insurgent stronghold, and you would enter the coordinates of the stronghold, and you'd press the button saying, "Drop a bomb here," and then, hopefully for you, not hopefully for the people in the stronghold, a plane would come over and drop a big bomb on that location. However, it turned out that the designers of this device had not considered all aspects of its usability. And one thing they hadn't considered was, what happens if the battery dies just after you enter the coordinate? Well, it turns out you can put another battery in, and it will automatically resend the coordinate. The problem is it resends your coordinate as the new coordinate. And as you can imagine, that had some pretty disastrous consequences. Okay, so to end this discussion about safety, I thought I'd pose this question for you. Think about the way gears are designed in cars. What can you think of as some of the safety concerns with the usability of this kind of design? Yeah, Jackson. Excellent. So one possibility is it's just too easy to put it into the wrong gear with bad consequences. What else? Yes, and I've forgotten your name. I'm sorry. Michael, yes.
So the one in the top right is like more modern design.
Yeah.
I believe it stays in the middle, and you just like push it forward or push it backwards, so you change it from reverse or drive. So you don't know at any given moment whether you're in reverse or drive just by it sitting there.
Oh, excellent. So you lose the visual feedback of the position to tell you what gear you're in. That's a great observation from Michael, yeah. And that's going to be one of the heuristics we'll actually talk about on Wednesday. Yes, Billy. That's right. So the middle one is much better designed to prevent you going accidentally into a gear. That's a great observation, Billy. Adrian. Exactly. So the button is presumably a lock. And that's another way to deal with that problem. If you're not holding the lock, you can't put it into park, for example. I once, when I was a teenage driver, I don't know how, I persuaded my dad to let me drive his car to high school. It was this Honda that had this really nice gearbox. It was like an automatic, but it had like 3 lower gears. And I discovered you could get it to rev up really quite nicely, if you were trying to sort of burn someone up at the lights by starting in a low gear and then sort of flipping it upwards. And I was quite a dab hand at flipping it upwards. And one time I was not paying attention, flipped it up a little too high, and put it straight into reverse at about 30 miles an hour. And there was this noise of sort of, nuts and bolts like going crazy under the hood. And I sort of pulled the car over to the side of the road, completely shaking, thinking that I would like put it in drive and that would be the end of it. And by some complete miracle, it just sort of pulled away fine, and it seems that I hadn't wrecked the gearbox after all. But it sounded to me like it was the end of that car. So I'm quite aware of that one. But going back to the middle one, is there actually a potential safety problem with that design? It might be a case, yes, Julio. Yeah, it requires you to look at it, really. And the other thing that's interesting, I don't know if you remember this, but there was a lot of concern a few years ago about what they called unintentional acceleration, right? There were all these cars that apparently just spontaneously took off. And in fact, I was on a committee to look into this. It was never really properly resolved whether this was due to software or whether it was due to sort of connections that grew. There were these things called tin whiskers. Maybe the connections were sort of shorting out spontaneously over time. But one of the big concerns was cars that didn't let you put the engine in neutral if you panicked, right? You're driving along the highway and you lose control of your car, right? It seems to have put the throttle on the floor even though you've done nothing. What do? So the obvious thing you're supposed to do is put the car in neutral. Well, if you're driving that car with a middle design, it's pretty unclear how to get that car into neutral, right? Whereas with the design in the bottom right, it's very clear how to put that car in neutral. You simply push a stick all the way up because you can't push it the whole way up because of the button. So pushing it as far as it will go generally pushes it into neutral. So anyway, there are lots of interesting safety issues, and again they're conflicting. Okay, so one of the things I want to close with in talking about this safety question is that there is a long tradition in the design of machines and software to blame the user. And one of the big changes in the whole field of usability has been to push back on this and realize that it's normally the designer to blame. And this was a famous incident in 1997 in which a whole US destroyer basically lost power and was stranded in the middle of the ocean for, I think, several days. And it turned out that it was because somebody had entered -1 into some cell in a spreadsheet. And that Excel spreadsheet caused a crash on some network which was connected to the propulsion network, which brought down the whole system and so on. But what was wonderful was that the commanding officer of the USS Yorktown said this afterwards. He said, people sometimes make mistakes and systems break. The trick is we've trained our crew. So he had been habituated into thinking that it was really their problem rather than, the terrible software. Okay, security. The one thing to point out, of course, is that it is true that to make the most secure system, usability is sometimes not in your favor. In fact, if you could make a system in which your user was unable to do anything at all, then it might be very secure, right? Someone was once asked, how do you make a secure laptop? And the answer is you bury it 10 feet underground. Then it's really secure. And hence, Dilbert's comment, in a perfect world, no one will be able to use anything. And that would indeed produce secure systems. But there are other aspects of security that are interesting from a usability point of view. One of them is, there's been for a long time abortive attempts to get people to sign emails. And I'm sure all email clients you use have some kind of signing, right? But for the most part, people don't sign their emails. And there was an incredible experiment done a long time ago, this is 20 years ago, by a student of Doug Tygar's in Carnegie Mellon. And what they did was they basically presented a bunch of users with one of these systems. And I think these were all actually computer science undergraduates. And they asked them to encrypt some emails. And what they found was that one of them was unable to encrypt anything at all. 3 sent the secret without the encryption. 2 knew they'd done it, but couldn't help it. And 7 actually sent something that was impossible to decrypt. So it doesn't matter if you have all this fancy cryptography. If no one can use it, then that's that. It also turns out that you can have much more simple-minded usability problems with security. So here's something that happened to me. So a few years ago, I got a message which pretty much said this. And this was from TIG, which is the infrastructure group here at CSAIL. And this kind of thing is really embarrassing. And the message said, we ran a password breaker on your password, and we broke it. And that's a polite way of saying, you're one of those bozos whose password is password, aren't you? It's like, get a life. You're supposed to be a competent human being. And I was actually really super puzzled by this, because I didn't think I was one of those bozos, and I thought I'd actually chosen a pretty good password. So the password I'd chosen was actually something like this. It wasn't this. But basically, I'd followed the recommendation of taking things I could remember. So I took, the name of a Beatles album and the year in which it was published. Not that I'm old enough to have been listening to it in that year. And I just concatenated these words together, right? And by all normal sort of measures, that should be a pretty good password, because there are a lot of words in the English language. So if you only have to find one word, that's easy. But if you have to find multiple words in combination, there are a lot of those. It turned out, however, that the version of Unix we were using had an 8-character limit, and it silently truncated my password. It truncated it every single time, not only when I set the password, but every time I used it as well. So I set this nice long password, and I used it, and everything appeared to be fine, but it never told me it was only using the first 8 characters. And the first 8 characters happened to line up perfectly with a common English word. So that's kind of bad. Another security problem that you have to bear in mind when you think about usability is that as a software designer, you're not only designing software, but you're inevitably going to be involved in the policies that people use to support the software. So here's a common policy that says that if, in order to prevent people using passwords being stolen, we should make people change their passwords every 60 days or whenever. Do you think this is a good idea? Is this a good policy? I do know your name, and I've forgotten it. Jocelyn, right.
No, I had to use something similar, I believe in high school, and I believe a lot of people just use the same password with one thing changed, so it didn't actually do anything.
Oh, that's a good one. So they typically try and game, the thing that checks it's not too similar to the last one, yes. So that's one reason it's not very successful. What else? Well, there's some evidence. Yes, Michael.
People start writing it down.
Yeah, this is what produces the yellow sticky on the computer, right? Because it just gets so annoying. But this is my favorite thing. This actually happened to me. I was working with a couple of people as consultants for a large corporation that will remain nameless that had this policy. And I sent an email message to the administrator at this company complaining about this policy in a gentle way, saying, this policy is kind of annoying. I don't think it's helping you with your security, and it's making us go through all this work of going to your website and doing the 2-factor authentication and so on to change, to change everything. So they didn't quite understand my message, and they sent me back a very friendly message saying, we quite understand that this is a burden for you. We'll take that burden away. And their message said, here, for all of you, we've done it for you. Here are your new passwords. And we've given you all the same password, and we're sending it to you in the clear. And that's what they did. So I think that was sort of delightful. And so but this is, of course, a typical thing. If you make a security process too unusable, then people will find workarounds. Okay, the final category of criteria for usability is, of course, accessibility. So in this room, there are probably 20 men, and a couple of you can't see the number there. A couple of you are seeing this. So some of you saw no difference between those two, and some of you saw the number disappear. And the reason that some of you saw nothing is because you're red-green colorblind. And that's, in fact, just one of many different kinds of colorblindness that exist. This was something I thought was kind of delightful. Some organization actually trying to demonstrate the risk of phishing actually showed a keyboard with 2 colors. And if you actually look at that under one of these plugins that simulates colorblindness, you can see that those would be indistinguishable. So how to deal with this? And this is really a much larger topic, and we don't, unfortunately, have time to look at it in this course. But there's a great initiative that you can find online called the Web Accessibility Initiative, which contains all kinds of good advice about how to make websites in particular accessible by doing things like providing alternative modalities. Don't just rely on images, also allow text. Make sure that if you have videos, they're captioned. Make sure that things can be accessed not only by moving a pointing device, but also by keyboard and so on. So the lessons, in short, are that we have these criteria. They're often conflicting, especially the ease of use criteria. Security is not only about usability causing risks to security, but the need for usability to support security. And the important thing to understand about accessibility is that time and time again, people have groused about making things more accessible. They say, well, why should I do that when it's only 1%, 10% of the population who needs this? Well, A, it turns out it's usually a much higher percentage of your audience than you think it is. And secondly, it turns out that when you make things usable for people who need various kinds of accommodations, you're normally making it more usable for everybody. And so that's a very important thing to do. Okay, so now I'd like you to do a little exercise to get into the spirit of this. What I'd like you to do is to consider subway turnstiles, okay? And just write down, this is just write down in a couple of words for each of these categories what you think one of these criteria might suggest as a potential problem if you were the designer of a subway turnstile system. This is actually one that's close to my heart because my very first job as a software developer was writing the software for one of these turnstile systems in the London Underground. And they're quite intricate and complicated systems. So think about each of these and think about them all. We're only talking about user experience here. So think about the experience of a user going through these turnstiles and how each of these criteria could impact the design of the turnstile. Okay, why don't we talk about it a bit? So learnability. What's an example of learnability? Of a learnability concern? Yeah, Billy. Oh, it's a great point. So I hadn't thought of that, but as Billy points out, this is very different from many other kinds of systems because you're basically watching many other users interact with it. And so if it's very obvious what they're doing, you can do the same thing. And that would suggest you'd better be careful not to rely on them on doing things that aren't easily observed, right? So there might be some details of the interaction that are not so easily observed. How about efficiency? Is it Julia? Oh, you're saying not having a physical turnstile makes it much more efficient. When there's a lot of traffic, absolutely, that's an interesting one. And what were you saying about your phone? That
Oh, no, this is like, so I'm from Korea, so this is the subway system that we use.
it is, in fact, in Korea, that's right. Do you actually know what they do if people go through without a ticket?
So the bars actually stick out from the side like this.
Oh, then they actually cut your legs off if you make the mistake of trying to go through without a ticket. So, but that's very interesting, right? So Julia's pointing out that simply not having, by default, having the gate open is very good for efficiency. What else is good for efficiency in these designs? Any other thoughts? Yes, behind you. Emily, right.
But I think that like in this picture, having multiple turnstiles is probably
Great, having enough turnstiles so you can do some parallel processing. Excellent. Let's talk about error tolerance. What kinds of things go wrong that you might want to tolerate? Yes, remind me of your name.
Lisa.
Lisa.
I guess when error tolerance is something going in the wrong direction, which
That's a good one. Someone going in the wrong direction. What else would you have to be concerned about? Adrian.
If you tap your card and decide not to go through, you can't just cancel your payment.
Ooh, yeah, that's one that pretty much all these systems fail on, right? Which is that once you've tapped your card, you've paid. There's actually an interesting one in London, which is, and I suspect this is true of all the systems that actually measure the distance you travel. In London, if you fail to tap your card on exit, because you see like an open gate and you walk through it, then it will simply bill you for the longest possible journey, which is a bad mistake. So you get to learn, you get to discover that you have to tap on your way out if you don't want to pay the maximum fare. What other error tolerance issues are there? Yes, Michael.
It's very easy for someone to get through without paying. You basically jump over that or go around on the metal bar.
That's right. It's quite easy. It's quite easy to get through. I'd probably put that more under the security category, but you're right. The system is more designed statistically to prevent most people from cheating rather than to be a complete barrier to entry. Yes.
I wasn't sure if you could register multiple taps, so you could end up paying twice.
That's a good point. That would be a very bad design. That's a good point. You'd certainly want to avoid that. In early online shopping systems. They said, don't click on the screen twice or you'll pay twice. And eventually, we invented sessions and we solved that problem. So the designer of this should know about that kind of behavior. Jackson. Yeah, so if you have certain kinds of system failures, they could be very expensive to the provider. Yes, Billy.
This might just be me being inconsistent sometimes, but sometimes I like tap when if there's not enough people around and I don't see like which one corresponds to which, I can tap and then it opens like the one adjacent to the one.
Yeah, exactly. In fact, if you just go around here to the alumni pool, they have that problem. A lot of people get confused. And I suspect that's why they have those arrows there. And the arrows, in a sense, are sort of evidence of a problematic design. Costa? For? Low balance. That's an interesting one, yes. And so I think low balance is interesting because normally they reject you, they reject you there and then, and if there's a big line behind you, it's kind of embarrassing and difficult. And so one thing you could say is that the low balance problem suggests you should have very prominent places where it's very easy to check your balance before you actually approach the turnstile. How about pleasantness? Any thoughts there? Yeah, Michael.
The interfaces are usually very abused and grimy, so that can be kind of unpleasant to work with.
Mm-hmm. That's a good point. Emily.
If you have a suitcase and you're trying to get them very narrow.
Oh, that's right. Yeah, there's a serious problem if you have a suitcase or something like that. And in a sense, that would go under the category of accessibility, right? Because, if you were in a wheelchair, also you'd have similar kinds of problems with these turnstiles. I was just thinking, actually, in line with what Julia said about this being the Korean design, this also has the advantage that you don't have to knock against a gate. It's much more pleasant to walk through. How about safety? What are some of the key safety issues you might be concerned about if you were designing a system like this? Yes?
If your exit is the same as the entrance, kind of like in a T, where you have to wait for the gates to open to get out, if there's some sort of fire in the station and people need to get out very quickly, it's harder.
Exactly right. Getting out, it's very important that people should be able to get out very easily. Tell me your name again. Emily, thank you, I'm sorry. As you can see, you can figure out the sort of half-life of my ability to remember names, and it's like one lecture. It's very bad. I'm working on that. Let's see, where are we? Security. Security is sort of pretty straightforward, right? Obviously, you don't want lots of people. Well, actually, it's interesting. You don't want lots of people stealing, but what else do you not want? Well, you don't want to rely on your software to actually open gates from the inside. This was actually a big problem in London, because in London, they actually had it so the gates could be locked, and they had a system that would allow them to unlock all the gates to let everyone leave. And you can imagine, I don't know what they're doing now, but if I would design that system, I'd be pretty worried about that being hacked. That what you would do is you would start a fire or something in a station, and then you'd lock all the gates. So that's potentially very problematic. How about accessibility? Darius? Yeah, those are certainly not wide enough for a wheelchair. And so, it's not clear whether even this design can be made to work with a wheelchair with protruding things. And one of the big problems, of course, is the amount of time that someone has to go through. The same thing happens at cross lights and things, crossings at lights. Jocelyn?
A lot of these don't have any kind of audio accompaniment, really slow messages, so if you have visual disability,
Yeah. Excellent. That's an excellent point. Michael?
It does seem to support blindness, accessibility for blindness as the yellow path with the textured walkway in one of the.
Oh, that's very interesting. Yeah, that's a very good point. I suspect that's what that's for. Yeah, and so maybe, in fact, this particular turnstile would be better designed. Yes?
It doesn't seem that if you have your hands full, if you're carrying a child or a suitcase, you could go through this. You have to free up a hand or something.
Yeah, exactly. You're not going to have an extra hand. So there are all kinds of problems associated with these things. And in general, you need to do this kind of exercise whatever you're designing. Even if you're designing a photo sharing site, right? Which you might think has no, you might think that you could preemptively drop out some of these categories. You'd be making a mistake, right? Because almost anything you build nowadays, particularly because of malicious people out there and all kinds of different forces, and almost anything you build will have all of these categories relevant. Okay, so that's all I'm going to say about criteria. Now I want to talk about heuristics, and we're not going to have time to talk about them all today, so we'll start talking about some of these heuristics, and then we'll finish up by talking about most of them on Wednesday. So if you could close your laptops, and we'll get back to chatting about this. So I wanted to say a little bit about this intriguing new field of design thinking. How many of you have heard of design thinking? So design thinking is all the rage now. And it can be viewed in many different ways. In some respects, people can see it as a great new democratization of design, a way to inspire people to build cool things. Other people think of it as the corporatization of design. It's basically someone who's figured out how to make a big buck on consulting fees by teaching people in corporations how to design things and making them feel that they're cool designers. But the major impact of design thinking has been to suggest a particular process that people should go through when they design things like software or indeed anything. And that process is that you start out by typically observing users or thinking hard about what your users need, and they call this need finding. Then you do what they call ideation, which means you throw out lots of ideas. And someone, a lot of people have joked. There's a very funny video actually by one of the design principals at Pentagram, which has the title, Design Thinking is Crap. As you can imagine, she's not a great fan of design thinking. And one of the things she points out is that she thinks design thinking was largely invented to inflate the profits of 3M, the makers of stickies, because almost all design thinking gurus tell you that when you do ideation, you should put lots of stickies on the wall. So that's very important. So you do all this ideation, and then you have to somehow coalesce. So this is sometimes called divergent and convergent thinking. You coalesce into some idea, and then you build a prototype. And this is a big design thinking idea. You actually make something physical, and then you try it out. This is, I think, a provocative way to think about building things. But for my taste, in my view, one of the things that is not ideal about this view of the world is that it doesn't place enough emphasis on the kind of critique that can be done during ideation. And in particular, it's my view that there's a lot of work that can be done very successfully in improving the quality of your design by just thinking hard about it, by bringing to bear experience, by having people who are experienced designers sit around and try and find holes in it. And really, that's what the whole field of heuristic evaluation is about. And it's been well known in the field of user interface design, and I think it can be applied very potently, actually, in all kinds of design areas. And in fact, it's widely used in design outside computer science. People talk about doing a crit, doing a critique, right, where people sit around, someone presents a design, and other people imagine ways in which it might fail. Okay, so we're going to be talking about these design heuristics, these user interface design heuristics, which try and give you something in the middle there. But first I want to just point out that these heuristics really can be applied at multiple different levels. There's the sort of physical level of what does the interface look like and how do you act with it and interact with it in a tactile way. Then there's a linguistic level, which is how does it communicate? And it might not just be through words, it might be also through signs. Then there's a kind of navigational level, what kind of paths can you take through a design? And then underlying all of this is a conceptual level, which we discussed last week, and which I think needs to be designed first before the user interface. So the way I think about it is that what you do when you do need finding is you crystallize the purposes of your product, and then what you do is you do conceptual design, essentially. You come up with an abstract characterization of what kinds of behaviors you're going to support. And then you design a user interface. You become concrete, and you say, OK, it's going to look like this. And this follows exactly the structure that you're following in your assignments, right? You did the conceptual design last week, and then this week, you're now going to be doing an actual user interface design. And then, in each of these phases, you can actually do some critiques. In particular, when you do the conceptual design, you can think about what you know about known concepts and reusing them, and you can apply the criteria that we talked about when we talked about concept design to polish that design and reject things that are obviously going to fail. And then similarly, when you do the user interface design, you can apply the user interface heuristics, which I'm about to tell you about. Now, of course, that doesn't mean that you're going to have a design that works, right? You could still end up with something that will fail horribly because you'd misunderstood something about how your users are going to understand it. So it's really valuable to then actually do some kind of user study where you put either the whole thing, or preferably you find a prototype that's less expensive to produce, right? So you won't be so unhappy if you have to trash it. You put it in front of users and you see how they interact with it. And you're going to be doing exactly this in your assignment, albeit in a very small scope. And it's a fun thing to do, but it can, truth be told, it can be pretty demoralizing because something that you thought was really obvious and straightforward turns out to be very far from obvious for your users. And of course, you end up going back, you end up iterating on this, right? And that's essential to any kind of design process, is that you learn from your mistakes. And you might just have to go back. You might discover something in a user study that tells you, oh, you know what, that color was really confusing, or that wording on my user interface was bad, or the layout wasn't right, or the navigation is wrong. But you might also discover, you know what, the underlying concept is wrong. The user doesn't understand that. Or, in the worst case, the user wants to use this product for something completely different. I've got the whole purpose misconstrued. So all these things are important, doing the concept design, the interface design that we're talking about today, and then user testing, which I'll say a little bit more about on Wednesday. One thing that I want to point out, though, is that I think there's a tendency nowadays to put almost all the emphasis on user studies, because user studies are very potent, and they're very concrete and straightforward, and also people like data, right? And there's a lot that can be learned from actually collecting data on how people use your stuff. And of course, for companies like Google and Facebook, it's very easy to collect data. You can put out 2 versions of a page and see how people interact with it. But I think it's also important to recognize that you can learn a lot just from looking at a design, if you're a talented designer, by applying all the accumulated experiences of designers that came before and applying these kinds of heuristics. And sometimes you can just guess, looking at something, it's not worth actually building this. Right? So if you saw, a pair of boots that look like this, you probably would not take them out into the rain and say, let's give them a trial, right? Because you don't need to think very hard, right, given your experience with boots, to know that these are going to be a problem. This is actually a rather lovely design project by a woman called Katrina Camprani. You should Google her, and she has a whole collection of unusable objects with delightful, egregious flaws. Okay, so now what we're going to do is we're going to talk about these heuristics, and we're going to go through these heuristics at the different levels, starting with the physical level. And each of these levels have different concerns. So at the physical level, what you're trying to do is you're trying to map the qualities of your interface to the actual characteristics of a human being, right? So, on the one hand, you've got things like questions like, where am I going to put buttons? When am I going to show a progress bar? What colors should I use, and so on. And on the other hand, there are things you know about the way humans behave. How fast does a human move a mouse, right? How much delay does a human being typically perceive? What can the eye actually perceive? So even if I think I'm designing for somebody who doesn't have reduced vision, right? What can I reasonably assume about what someone will actually be able to resolve? So the most famous heuristic in this area is what's called Fitts' law. How many of you have heard of Fitts' law? Okay, a whole bunch of you. But many of you haven't. So here's the idea. The idea is basically to model the problem of moving a pointing device from an originating point on the left over to a target on the right. And what Fitts' law tries to estimate is the time it would take to move to that target. Okay? So the time is estimated as follows. First of all, there's some reaction time A. Right? So at the beginning, before you even move there, you've got to know you want to move there, or you've got to recognize that it's over there and that's where you want to go. And then there's the time to actually move. And the time that it takes to move is dependent on some constant b, which is basically how quickly you move. And that will obviously change with factors like age. Young people will be able to move much faster. But then there's this important quantity that's known as the index of difficulty, which is the distance away divided by the width. So the idea here is that obviously the further away something is, the longer it's going to take you to get there, right? But if you think about it, the smaller it is will also determine how long it will take you to get there. Because if it's really, really big, you can just sort of get there, you know, and you'll be there, right? Wherever you move the mouse to, it's probably going to be there because it's a big, great splodge, right? But if it's a tiny little thing, right, either you're going to have to slow down, or you might even miss it and then have to sort of oscillate back and forth until you eventually hit it. And that takes time. And so the rule is, you should keep, if you want to minimize the amount of time people spend hunting for things, you should keep features close and big. And if you want to play with Fitts law and see how well you fit Fitts law, you can look at these URLs afterwards, but they're nice little simulations people have done where they ask you to actually do some of this tracking, and they draw graphs for you and tell you, what your average times are and so on. So here's an example, which I actually noticed only a couple of weeks ago when I did an upgrade to the software on my iPhone. So it used to be, when the new iPhone came out, they changed the way, they changed the user interface of interaction for closing apps. And it's really quite obscure. Let me show you how it works. So here is someone explaining how to use this facility.
Hello and welcome back to another Technology Guru video. So a little iPhone 10 quick tip here for you. It took me a little while to figure this one out. Again, it's not complicated, but it's slightly different. So if you're wanting to force quit or kill an app, and it basically reopen the app if it's locking up on you or for other possible reasons, what you're going to want to do is swipe up from the bottom of the phone. And when you swipe up, basically stop in the middle or the center of the device. And then basically you need to, again, it's very kind of touchy, but you do get used to it. And then what you can do is once you see all of your open apps here, you can actually force touch, so you can actually press down slightly harder. And then now you can see the red minus symbols in the upper left-hand corner of each app. You can either tap on the minus symbols to go ahead and force quit that app, or what you could do is you could swipe up like you normally would within the older iPhones and iOS versions. So again,
So I think this is really wonderful, right? So first of all, notice that he starts by saying, essentially, this is completely unlearnable. He said, he sort of says, you probably wouldn't figure out how to do this. And I can tell you, when I first faced this interface, I had to Google to figure out how to do this, because you would never come across this by accident. Secondly, I don't know if you noticed, he talked about it being kind of touchy. Did you hear that? And it was more than kind of touchy, because you had to sort of press halfway up, not the whole way up. And then you have to do this force touch, which is another rather subtle gesture, to get the little red minus sign to appear. And then interestingly, he said, well, you could at that point just sort of swipe up. I actually didn't know that until I found this video just yesterday, preparing for this lecture, and I didn't know you could do that. So I'd been using this thing for months, pressing on the red minus sign. And what would you say Fitts law tells you about the red minus sign? Yes, Julia.
It's really small enough in the corner, so it actually might take some time to actually reach the button.
Yeah, it's really small, and so it actually takes you quite a long time to touch that red minus sign. And it's also not very error tolerant, because if you actually miss the minus sign, then it ends up opening the application. Yes, Ayush?
Yeah, right. I think a similar example I can think of, especially you can see it on the screen. So in iOS, the back gesture is a good example of Fitts law, because I think you have, previously you only had back buttons on the side. For example, on the message screen, you can see the back button. But most people just use the gesture, which as long as you're on the left side of the screen, the whole area acts as a touch area.
Ah, excellent. That's a very interesting observation, that the ability to swipe left and right to move backwards is a sort of Fitts law-inspired replacement for having to hit that tiny little button. That's a very good observation. Thank you. Okay, so what actually they did was they actually got rid of this. You have to wonder why anyone thought this was a good idea, because they had this nice thing where you could just swipe up to get rid of an application. And in the update they did, I think in June of this year, they returned to the swiping gesture they'd always had. Okay, so now I want you to do a tiny little exercise, and here's the exercise. One of the differences between Windows and the Mac is that on Windows, the menu bars are associated with the applications, but on the Mac, they always float to the top of the screen, and they switch between depending on which application is active. You can read all kinds of arguments online between the fans of Windows and Mac about what they think's better. And here's what someone said, and this is literally a quote. On Windows, the menu bar is right there. No need to move your eye to another part of the screen. So what I'd like you to do is just think for a minute, and you can talk to the person next to you, and write down an opinion about who Fitz's law would support in this argument, this point of view or someone who had a different point of view. All understand the question? Interesting. So Ali points out that if you have multiple applications open at the same time, then you won't actually even see the menu bar on the Mac for your application until you actually activate that window. So I think that's right. There is a certain sort of lack of visibility there. Billy?
I'm Team Apple, and I like the idea that it's always on the top left corner, and I can just move my mouse all the way up, and it'll just stop me where I need to go, versus having to stop at exactly that very small height of the little line of menu windows, wherever it may be.
Right. So I think that is actually, so Ali has pointed out that there are a bunch of sort of psychological reasons that the Windows design is arguably more straightforward and perhaps a little less surprising. And I think that's probably why it persisted for so long. I don't know if Windows still uses this. Maybe, are there any Windows users here who can tell us? It still uses this? Yeah, and it makes sense because, it does have certain kind of cognitive advantages, as, the one, for example, that Ali explained. And of course, it also means, notice that on the Mac, by the way, it means that the menu bar gets separated from the rest of the taskbar. And that's slightly weird. So the Windows design definitely has advantages. But I think Billy's point is correct, that Fitz's law actually suggests that the Macintosh design is going to be much easier to use. And the reason is that even though the menus are potentially much further away in the Macintosh design, as Billy points out, you don't need to worry about exactly where you land on the bar. And the reason for that is that essentially the size of that menu bar item is infinite, right? Because it just extends off the screen forever. So all you have to do is a kind of swipe in the right direction. And if you get the right direction, you don't need to stop your pointing device when you get to the top, because it will just stop naturally. And so for that reason, most people think that the Fitz law design militates in favor of the Mac. So by the way, if you want to do a fun little experiment, one of the things that you could play with yourself is to look at what happens. When you take one of these menus, and you pull it down and you have all these options, right? In many cases, there's a secondary menu, that the menu is actually hierarchical. And so that if I click here, there's actually another menu that appears, out here with its own options. And now there's a very interesting Fitz law question of how you actually select these options. And if you experiment with this on different systems, you will see that they behave very differently with respect to where you can actually move the pointing device. And so one of the interesting questions, which is not exactly Fitz law, but related to it, is what path must you actually follow from here to here? And will you actually lose the context if you don't, for example, go like that? If you, for example, went in that direction, and that, if you play around with it, you'll discover is designed very differently in different systems. Okay, so that's one example of a very physical level idea. Another idea is the idea of perceptual fusion. So you've all seen these nice little flip books, right, where you can actually give someone the illusion of motion by simply showing a bunch of stationary images. And of course, this is the way movies work, right? And the reason they work is that the human brain actually fuses events that happen within a certain temporal proximity. So roughly speaking, if things are within about 100 milliseconds or a tenth of a second, then we perceive them as not being distinct events, right? So what do you think some of the consequences are of this for UI design? What's some of the most obvious consequences? Yes, Costa. Sorry? If you have any animations, this will tell you what kind of frame rate you need for the animations to look smooth. Excellent. What else will it tell you? That's exactly right. If you actually want to make it very explicit that there has been a change, a transition, a change of state, you'd better not make it too quick. I hadn't considered raising that one, but you're absolutely right. That's very important because it will look instantaneous, and the user might not even recognize that something's happened. What else does it tell us? Yeah, Michael.
It upper bounds how long something will take if you want it to make it instantaneous.
Yes, if you want something to seem to be instantaneous, you want to make a really smooth experience, you'd better get it done within 100 milliseconds. And it tells you in particular that going down from 30 milliseconds to 1 millisecond is really not going to matter because your user simply won't notice. The other thing it tells you is that if you need to have some delay that's more than about the tenth of a second, then you should show a progress bar. Because otherwise your user will be confused because they will actually perceive the difference. Okay, so let me see. Let me show you one more quickly, and then we'll have ended this whole section. So another thing related to sort of perception is what sometimes goes under the term Gestalt principles of grouping. It's a psychological idea, and basically it says that the human brain perceives things as being conceptually grouped if they have similar size and color and appearance and are physically grouped together. So if I give you a web page that looks like that, you're going to be very confused. Whereas if I give you a web page like that, right, you see immediately what you're supposed to be doing. So the lesson is that visual layout is very important to convey structure. And here's one example of that. This is very commonly done, but it seems to me slightly problematic. That the way this interface works, this is Google Forms, is that when you check one of these things, right, that is actually selecting what the outcome will be of performing an action from that menu. And we've sort of become familiar with that, and probably most of us don't even think of that as being confusing. But it does violate this principle, because if you were encountering this for the first time, you might not realize that these two very distant things are in fact related. Okay? So that's all I'm going to say today about heuristics. On Wednesday, we'll go on to the linguistic level. And I'll also have some fun things to tell you about dark patterns and other topics. So see you then.